Greetings. In this video segment, we are going to learn about metals, how they are extracted, and some of their properties and uses in our daily life. And for this case, we're going to start with our metal that is called sodium. Sodium is an alkali metal. Its atomic number is 11 and it has an electronic configuration of 281. It occurs as rock salt, that is solid sodium chloride. Also, it can occur in a dissolved state, that is as dissolved sodium chloride. The ores that we can find our sodium, the chief ore is rock salt, which is sodium chloride, and other ores include saltpeter, which is solid sodium nitrate, and trona, which is sodium hydrogen carbonate, sodium carbonate dihydrate double salt. The extraction process for us to obtain this sodium metal, it is extracted by electrolysis of molten sodium chloride, and it is done in a Downs cell in a process that is called Downs process. Now we are going to learn about this Downs cell. This Downs cell, it consists of the following. If you can see in our two-dimensional diagram here, if you look at it clearly, you can see that our representation of the Downs cell here, it has some lining that is made up of iron. So this is the iron lining, and this iron lining is filled with fire bricks. These fire bricks are going to help us to maintain the high temperature so that the electrolyte does not crystallize. Remember, this is the electrolysis process, and in electrolysis there are some factors that we need to know, that we have an electrolyte, and our electrolyte for this case is molten sodium chloride and calcium chloride that is fused, or that is combined. And also we are supposed to have the cathode and the anode electrodes, whereby here we are using a circular steel cathode. There are two, one is here, another one is on this side, and also we are going to use a carbon anode, which is also a graphite anode. So the anode is made of graphite, which is here. This one is made up of graphite, and for you to identify the anode and the cathode, remember the anode, it is always connected to the positive terminal, and then the cathode is connected to the negative terminal in a given cell. So that is how you can identify it, and from our Downs cell you can see that our anode is carbon anode, or it is a graphite anode. Why do we use a carbon anode? It is because it is inert even at high temperature. That means that it doesn't react with the electrolyte. So graphite cannot react with an electrolyte, nor can it melt, because its melting point is a little bit higher. And now that we have shared about that, if you can see very well from this representation, the cathode is made up of steel, the anode is made up of carbon. What will happen if we use steel as our anode? If it is made of steel, it will react with chlorine at high temperatures. Therefore, we do not use a steel anode. Now, the melting point of sodium chloride is 800 degrees Celsius, and maintaining such a temperature until all the sodium chloride melts is quite expensive. It is economically expensive. Therefore, calcium chloride is mixed with sodium chloride, whereby calcium chloride is acting as an impurity. And as we know, impurities lower the melting point. Thus, calcium chloride lowers it from 800 degrees Celsius to 600 degrees Celsius. which is relatively cheaper economically because less electricity is required for that temperature to be attained. And now we want us to know the reactions that are going to take in our cell. Remember, this is the down cell. As we have explained, is that the down cell is made up of iron lining that is filled with fire bricks, and these fired bricks, they are going to maintain the high temperature so that the electrolyte doesn't crystallize. Now we're going to proceed to know what are the reactions that takes place in the anode and in the cathode. So we're going to start with the reaction that takes place at our anode. Remember, the anode is made up of carbon, and the carbon anode is graphite, whereby we have said it is inert, it doesn't react with the chlorine. Even at high temperatures, it doesn't react. Therefore, our anode is going to allow the reaction to take place by accepting the anions. It attracts the anions, and the cathode attracts the cations. The anions from our sodium chloride that gets inside this down cell are chloride anions, which are the negatively charged ions. Therefore, they're the ones that are discharged here at the anode, our carbon anode. And if you can see very well from this down cell, is that you are going to see as steel gauge diaphragm. It is somewhere here. This is the steel gauge diaphragm, and this steel gauge diaphragm is going to help us to prevent chlorine gas from recombining with sodium, now that sodium and chlorine are quite reactive. So that is why there is this diaphragm that is made up of steel. Then when the reaction takes place at the anode, therefore we have the anodic equation here, whereby the chloride ions are going to gain electrons. As they gain electrons to form chlorine gas that gets out of this down cell from the hood. And this chlorine gas that gets out, being that it is quite hazardous and toxic to the environment, it is not released to the atmosphere. It can be kept for other uses. And that is what that happens in the anode. Now we are going to proceed to the second case, whereby we are going to obtain our sodium by getting it from the cathode. Remember, we have said you can identify the cathode by looking at the terminal. It is connected to the negative terminal. The cathode is made up of circular steel, and steel is not reactive in this case. So also it is inert, it cannot react with sodium. And remember, the cathode attracts cations, and the cations present here are sodium ions and calcium ions. So you'll ask yourself a question, what will happen? We didn't need calcium, but we're going to obtain it. So we are going to explain what will happen. Remember, as we have said, at the cathode, it is sodium ions that are going to be released there, whereby sodium is going to gain those two electrons and then form a molten sodium metal there. And this is the explanation whereby sodium and calcium is deposited, but sodium is preferentially discharged because it is below calcium in the electrochemical series, and sodium is obtained in liquid form because it has a low melting point than the electrolyte. Our electrolyte, do not forget, it is molten sodium chloride and calcium chloride, and it is collected at the upper part of the cell since it has a lower density than the electrolyte. So it is collected here because it has a lower density than the electrolyte, and our electrolyte, still I remind you, it is molten sodium chloride and calcium chloride. So we obtain our sodium like that, but it contains an impurity, and the main impurity that is obtained is calcium, which is removed during cooling, since it crystallizes, leaving sodium as a liquid. And that is what that takes place in the down cell when we extract sodium. From that, we're going to know the physical properties of sodium. This is our sodium metal. As you can look at it, it looks white, but that is not the color of this sodium metal. That white substance has been formed because sodium is quite reactive. Sodium reacts with air to form sodium oxide, which is white in color. So our sodium that we are going to have there today has a coating that is white, which is formed due to the reaction of sodium with air. And also sodium oxide can react with water to form sodium hydroxide, and the sodium hydroxide that is formed can react with carbon 4 oxide gas to form sodium carbonate and water. So that is some of the chemical properties of sodium when it is exposed to air, and it is quite evident here today with our sodium. Looking at our sodium metal, one thing that you're going to realize is that it has a white coating. This white coating is made up due to its nature being so reactive. But if I can cut it like that, you can see a shiny metallic luster there that fades almost very immediately. Just look at this. These are two metals. This is made up of steel and this is sodium, and it is shiny. So one of the physical properties of sodium, it is easily cut because I've cut it with a scalpel. Number two, it has a shiny metallic luster. This is water. I'm going to place my water inside this beaker and then transfer it from this beaker here. The beakers are clean to these other smaller beakers there. We are going to address a property of sodium whereby sodium, if placed on water, what happens? So this is sodium metal here. When you place it in water, it is going to form a ball that darts on the surface of water as it produces hydrogen gas, and it is going to form sodium hydroxide. How are we going to know that sodium hydroxide has been formed inside our solution? Now, sodium hydroxide is a base. With me here are litmus papers. One of them is a red litmus paper, another one is a blue litmus paper. So we are going to dip a red litmus paper inside this solution, and what will happen is that the color has changed to blue. So this is to confirm that it is basic or alkaline. But if I place it in water, we are saying the color remains. So this was initially water that has been turned to a base. And I can also use a blue litmus paper, and if I place a blue litmus paper inside the solution, it remains blue. What does this confirm is that our solution has been changed to be alkaline after sodium reacts with water. And also we can use our indicator, which is phenolphthalein indicator, whereby phenolphthalein indicator is a colorless indicator. If I place it inside a neutral solution, it remains colorless, but inside this solution it is pink. Just to prove that, remember, I've placed my sodium hydroxide inside this beaker there, again I can place another smaller sodium metal inside there, and you will see how the color will change instantly to prove that sodium reacts with water to form sodium hydroxide and hydrogen gases that you can see getting out like smoke. And those are some of the physical properties of sodium, and being that sodium is a metal, it is a good conductor of heat and electricity. So I'm going to burn sodium using a non-luminous flame, and you're going to see the color of the flame of sodium. So sodium burns with a yellow flame. So if you are to do a practical and you see a yellow flame from a salt, that is confirming the presence of sodium. Another thing that you should know about sodium, it is that these are some of the physical properties of sodium. It is easy to cut, it floats on water due to low density, as a metallic luster when freshly cut, good conductor of electricity and heat. The chemical properties are, it reacts with air. Remember, air is a mixture of gases, one of them being oxygen. That is, sodium has a shiny metallic luster, but when it reacts with air, it forms sodium oxide that is white in color. This sodium oxide can react with water to form sodium hydroxide. And then sodium hydroxide can react with carbon 4 oxide to form sodium carbonate and water. It also reacts with cold water, whereby it forms sodium hydroxide and hydrogen gas, but it does not react with steam because it reacts quite explosively. When it reacts with water, already we have shown you in the video how the reaction takes place. When you burn sodium in air, it burns with a yellow flame, and if it reacts with chlorine gas, it forms sodium chloride gas, which is white fumes. Some of the uses of sodium include, sodium vapor is used in street lamp, which gives a yellow light. Remember, when sodium burns, it produces a yellow flame. It is used in the manufacture of sodium cyanide, that is used in the gold extraction. And finally, the alloy of sodium and potassium is used as a coolant in nuclear reactors because it's liquid at room temperature. And that makes us to come to the end of the session about sodium, and I'm going to take you through the notes that you can take.